In this video, we're going to look at debugging multiple threads in Rider. So sticking with the same project, I've added an extra class, threads.cs, which has an execute method. And all I'm doing here is I've created a few threads just for us to play around and look at the debugging UI. So I'm creating 3 threads. They are named, so we'll see them in the debugger. Thread 1 calls doWork1. Thread 3 also calls doWork1, but thread 2 calls doWork2. And we're also creating a thread via task.run, which calls doWork3. And then finally, we're creating a long-running task. So we're just doing standard async await. I'm not awaiting it here because I want it to be fire and forget. So that squiggly warning is because I'm not awaiting it, but that's fine. So these doWork methods, all they're doing is an infinite loop where we do a console write line and then we sleep for 2 seconds. Ignore this line, I'll come back to this shortly. That's for something else I want to demonstrate. And doWork1, doWork2, and doWork3 all do the same thing except a slightly different message. And if I go to the top, this execute method is just in program.cs. I'm just calling threads.execute. So it's a static method. So let's debug this now. So I'm running our application in the debugger. And we can see that every 2 seconds, we're getting these messages appearing. If I go to our hard-coded podcast source and just bob a breakpoint there, and then go to the HTTP and run this. So we've now hit our breakpoint as we've done before. So let's revisit this debugging pane down here. We've seen this already in the course, but we've kind of like skipped over this bit. And this shows all the different threads. So I can click through and you'll see that the call stack which we've seen relates to the selected thread. So this top one is the current API request that we've made. When you see .NET TP worker, TP stands for thread pool. And you've also got this thread pool gate, which I believe is responsible for creating these different thread pool workers. But quite often when you see .NET TP worker, that is a async await call, that kind of thing. So we can see here, this is all asynchronous. We're using task and the caller will be saying await. And if we click through these, we can see this is our do work. And this one, and I think this one is something completely unrelated, but this one will be the one we've run with task.run. And you can see that the call stack here actually says our do work. If I scroll down a bit further, we can see our name threads, so 1, 2, and 3. You will also see these squiggly symbols here. That squiggle means that the thread is currently stopped, and it's stopped because we're paused in the debugger. So another tab we've not really looked at so far is this parallel stacks. And if I click on this, then we get this diagram. Now it's worth pointing out, if you're following along, if we go back to threads and variables, this call stack view, if I right click on it and say Rider show hide library frames, so that's showing all the library methods as well as your own code. If we go back to parallel stacks, this has suddenly become quite big, like one of the threads is actually huge. So if you see it like this, then go to threads and variables, right click and say hide library frames. So then this is a lot cleaner now. And we can see we've got a call stack in here as well. So we can go through the call stack. So that's for this thread. And now we get to the reason why I've got 2 threads calling the same method, because I wanted to show this. These boxes are grouped by threads that call the same methods, so have the same call stack. So you can see this says 2 threads, and if I hover over it, it says the thread names. So actually, if I just change back to threads and go to the top, so we can see this for context. So if I hover over, we've got my thread 1 and my thread 3, and that's do work. So we can see my thread 1 and my thread 3, they both call do work 1. We've also got my thread 2, so that's the only thread that calls do work 2. So it's its own grouping. So I've intentionally done this just so I can show that this is grouping by call stack, and some of these boxes will contain multiple threads. So we can see that this one has 6 threads. And we can also see this one, which is doWork3, but that's called net TP worker. Do you remember me saying that that was very async await related? So that is going to be like this one. which is using the task stuff. So now if we move over to this tab, the tasks tab, so we can actually see that do work 3. So this one, it's currently running, so the task is active, and we can see that here. It gives information about the location and the initial location. We can also see in the tasks this line here. So the create long running task, which is this one. And actually, if I scroll down a little bit, we can see that was this task delay. And we can see that says awaiting, that's the status. And it is because it's not been 10 minutes, so we are currently awaiting that task. This view you can also view as a graph as well. Another very cool feature in this, which is fairly new, is the ability to freeze threads. So if we go over to here, and you can do this from different views as well. I can do it from here as well. We've got these options, or we can do it from here. We've got the options here. So sometimes when you're doing multi-threaded code, you want to isolate just one thread and stop the other ones so you can just focus on that one thread. So once we're paused in the debugger, what we can do is you could take a particular thread and right click and say freeze other threads. So that's one option. Obviously that's going to stop all threads, which I don't want to do at the moment. I'm just going to, for this demo, I'm going to freeze everything that does a console log. So let's do my thread 1, freeze that thread. Let's do my thread 2, freeze that thread. And my thread 3, freeze that thread. There was also the other one, I think it was this one. Right click that one and freeze that one as well, because that was the other do work. So now if I continue playing and go to the console, we can see that it stopped logging out these messages. But I should still be able to run this. Let's get rid of that breakpoint and continue. Do that again without a breakpoint. And I should still be able to run this and get my data back, because this output does not depend on those threads. But it's really powerful that you can just freeze some threads to help you investigate an issue and isolate a particular thread that you're trying to work with. Another useful tip is we looked at breakpoints before. So if I put a breakpoint here, and remember when you right click on it, you get more options. So we're not currently paused in the debugger. So we're missing some options here that we would get if we were. So if we go back to my HTTP request, run it, so I'm paused in the debugger and try again, right click, we've now got this option, suspend only on a specific thread. So if you've got multiple threads calling the same method, and as part of your investigations, you need that breakpoint to only be hit from a particular thread, then you can do this as well. Speaking of breakpoints, if we go back to threads, so I mentioned about this before, this is just an object. If I go to this class, it's just got a string called message. And with each of these, I'm just setting that message. If I just bob a breakpoint here and then resume, it's not going to hit it because I've suspended all threads. So let me just pause the debugger. And if I right click and say unfreeze all threads and then continue, we're now going to hit this. So what I wanted to show is that if you've got an object with a property in, and I've actually got it down here from beforehand, but if I delete that, so I got that here by right clicking and went to add to watches, or another option is you can right click here and say new watch and start typing, and that right click new watch is the insert key. But when you expand this and you've got your property, you can right click and say set data breakpoint. Now what this does is it'll break when that property gets changed. So if I do that, so you can see it's got an eye icon here to indicate that a data breakpoint has been set. Now if I continue, let's just get rid of that breakpoint and continue again. We can see it's hit that data breakpoint, and it's even shown the previous and the new value. So that's actually useful not just in multi-threaded code, but in general, data breakpoints if you just want to see when a property of an object changes. So with that, that's actually the end of the debugging module. And Rider's got so many different little things. There's going to be bits I haven't covered, I've not been able to cover, but that covers most of the stuff. I've intentionally not covered anything about performance debugging because we'll look at performance later on in the course. But other than that, that should give you a really good grounding of how to debug in Rider. So when it comes down to it, the main thing you do in an IDE is work with code. And I think we can all agree that code should be source controlled. And the clear winner nowadays is obviously Git. So it's Git that I'm going to demo in this video, but Rider does also support Mercurial, Perforce and Subversion. But as I say, I'm just going to be demoing Git here, and as you'll see, Rider has a very nice, deeply integrated Git experience. So here's a project I'm just going to use to demonstrate the Git functionality in Rider. If you look along the left-hand side, these different panes, there should be one called Git, which is Alt and F9, or might be different depending on your key bindings. If that's not there, then choose ... it'll be hidden in here. And then when you go to it, it should then appear down here. As a side note, if you want to tidy this up and get rid of ones you don't use, you can right click and say hide. So if we go to the Git pane, then we see this along the bottom. So first of all, this video is not a Git tutorial. I'm assuming you've used Git. This is more how to use Git in Rider. This should hopefully look quite familiar. So on the left-hand side, we've got branches. So we've got local branches and remote branches. In the middle, we've got the log, the Git log with a list of commits. And there's a bunch of filters along the top, which we'll look at. On the right-hand side, you've got the details of the currently selected commits. So we've got the files, and we've got the commit details with things like the SHA, the author details, the timestamp, and branch information. Right near the start of the course, I mentioned about keyboard shortcuts to move these panes around, not just Git, but any panes. So if you remember, if we go over here and go to resize, we can see them here. So they've got stretch to top, stretch to bottom, and maximize tool window. So this is actually really useful for this log window, especially the maximize tool window. So the stretch ones do this. And the maximize tool window, which in my case was Control Shift and apostrophe, basically toggles it being full screen. So this applies to all panes, but for the Git log, this is especially useful because for a big project, this log might be quite busy. And just being able to do that and have the full page viewing it is quite handy. So in this example, you can see that I've got my main branch, which is behind the remote origin main by 1. Now I've put the commit message commit by Bob. Ignore the fact that it says my name against it. Pretend this is a commit by someone else that's on main, and I'm 1 behind. I've intentionally done this so I can demonstrate rebasing in a bit, but we'll come back to that. So let's work through a scenario from when we first start writing the code to creating the PR. So to keep it simple, let's say the requirement is to create a new API endpoint. This is a web API project, and all it has to do is return hello Dome Train. So the first thing I would do is create a feature branch. So there's a few different ways I can do that. I can right click here and say new branch. I can do it from over here and say new branch from main. There's also on the top left, we've got this drop down, which shows your current branch. It shows some kind of indicator, see this blue icon? So that shows that we are 1 commit behind. So at a glance, we can see that. And I can update, so that's like a poll kind of thing, which I won't do now. But then we can work with our branches here. So, well, we'll come back to this a bit later, but we can create a new branch here as well. Another option is this menu here, as well as getting to it via here, you can press Control Shift and backtick, and then that pops up exactly the same menu. So if we could say create new branch and we say new API endpoint, that'll do. So press enter. So that's created that now. So we can see down here that's appeared. We've obviously not got a remote representation of that yet. So now let's start with the feature. So I can see we've got a test project, and in the next module we'll talk more about tests, but let's go to this one. So this test project is making an API call to my demo controller. But while I'm here, I've noticed that the file name isn't ideal. So let's do Control RR to rename this to fix it up, just while we're here, because it's always good to leave things better than how you found it. Now I can do Control RR and rename it here, just to quickly show you a different refactor, which I don't think I showed you earlier on in the course. If we actually just change it manually, let's call it my demo endpoint test, because that's what the controller is called. Then if I'd done Control RR, it would have intelligently renamed the class and the file name and all